All right, we're moving on to section 1.2. We didn't talk about this on Thursday, so this is new territory, unless you've taken statistics before in some fashion. So let's see what we can learn about data classification. So, first of all, notice that we can split the data from statistics into whether they're qualitative or quantitative. Now the key here is not to get confused between these two. Notice that the first one has as its base the word quantity, which suggests a certain number of things. So you're likely to get numbers that have to do with the quantitative one. Numbers. Over here for the qualitative, you typically don't see numbers. For example, if your characteristic of interest is eye color, well, if you look at the person next to you, you don't see that they have an eye color of 7. Sort of silly, right? Well, that's what qualitative means. You're not going to use a number with it, but you will use something like a word, like blue. Maybe the person next to you has blue eyes, or brown eyes, or green eyes, or maybe they're from another planet and they have purple eyes with yellow polka dots. Wouldn't that be exciting? Well, anyway, you get the point. Focus on this one. It may have been a while, but I remember confusing the two because the words look so much alike if you're breezing through your reading. But look for the word quantity in that second one. And that means there's numbers associated with it. Now, that's one way of dividing up the data, qualitative versus quantitative. You can also have discrete, continuous, or neither. That's another way of classifying them, or by the level of measurement. And we'll get to all those. So qualitative, quantitative, that's our first step. Next, as I said, qualitative, notice there's no quantity there. So we're talking about categorical data, putting things into categories, like blue eyes, green eyes, whatever color eyes, that's one possibility. Labels, descriptions of traits, usually not associated with numbers. The second, quantity, means you've got counts, you've added up how many sheep there are, for example, or you've taken a 2x4 and checked to see with some measuring tape how long it is. You end up with numbers associated with that kind of data. Now, there are some that, of course, there's always a gray area, but usually you can categorize data as qualitative or quantitative. Qualitative, remember, you don't see quantity there, so these kinds of data will be descriptions or labels. The quantitative counts, so you're counting them up with your fingers or whatever you need to do, or taking measurements with some kind of device. So here we've got a little test for you. Maybe you want to hit the pause button. I know you want to pause me. You're bored already, right? No, of course not. So you want to take a list, A, B, C, and D, and for each one of these descriptions, make a guess as to whether we're talking about something that's qualitative or quantitative. So hit the pause button, write down your answers so you can't cheat later. Write down your 4 answers, then hit the unpause button again. See what you've got. Okay, first of all, paint has the descriptions. You don't go to the store and say, I want a number 7 paint. No, that's not it. You might say you want some blue paint, so you're talking about qualitative data for the shades of paint. Second, that kind were rankings. So they're qualitative data. You don't have a number associated with them. Third, amounts of dye are measured, so you get a number with it. It's quantitative data. And last of all, how many paint choices? You can count them up, so it's quantitative data. Did you get them all? Hope so. Now, we've got another way of splitting up quantitative data. Remember, these are numbers, and there are 2 ways you can split up those quantitative data. Some of them are continuous, some of them are discrete. Now, one thing to keep in mind is that when we talk about discrete, we're usually talking about chunks of parts of data. So for example, if you were counting how many people were in a classroom, you would go 1, 2, 3, 4. You would never go to 1.7. You can't have 1.7 people in a classroom or anywhere. So those are what we're talking about when we're talking about discrete data. Remember the qualitative and quantitative? Well, the quantitative, first of all, we have the discrete data. That's the ones that come in chunks, discrete chunks. Counts. Usually there's no between different numbers associated with those quantitative data. Continuous are the other ones. Usually there's some kind of measurements. For example, taking someone's weight or taking someone's height. There's no going from 5'8" to 5'9" with nothing in between. It could be anywhere in between. Since it can be anything in between, it's not discrete. It's continuous because there are an infinite number of possible measurements between 5'8" and 5'9". Discrete versus continuous. Remember, they're both quantitative data. We're talking about numbers. So here's a mini quiz for you. Hit the pause button. See if you can get all 4 of these right. Continuous or discrete? Do they sort of come in chunks, or are they continuous lists of numbers? Fahrenheit, temperatures in South Carolina. Numbers of houses in a city. How many elliptical machines are in every YMCA in your state? Heights of doors. Since temperatures can be measured to any level of precision, like for example between 59 and 60 degrees, could be anything in there. It doesn't come in chunks. Second part, did you get this one? Numbers of houses, these are counts, so it's discrete data. Come in chunks, counts. For part C, did you get this as discrete data? Again, how many elliptical machines? We're talking about counts, so it's discrete data. And just a reminder, all of these we're talking about here are quantitative data. There's numbers associated with the data. And for heights or measurements, and again, can be anywhere between 2 inch levels. So between 69 and 70 inches, or between 3 inches and 4 inches, there are an infinite number of possibilities between the two. So it's continuous. Next, the nominal level of measurement. Okay, so we're talking about levels of measurement. I'll give you a heads up here, and hopefully a little bit of an idea of how to keep these straight. There are 4 levels of measurement, and there's a name for each one of these. As you can see here, the first level, oops, try that again. The nominal level. Now, I have a hard time keeping these straight because there are 4 of them. So what I do is use NOIR as a mnemonic device to remember the 4 levels of measurement. Now, I do a sneaky thing, and this is a little trick you can use, and you can create your own. So some of you, I'm sure, are familiar with Domino's Pizza. Now might seem like a strange thing to mention, but recently they have started doing commercials for Domino's that include some strange sort of a monster. Now, some of you might remember that was called a Noid. This is the Noid monster, or the Noid person that's trying to keep people from getting Domino's Pizza. Now, what I do is I can remember the Noid, but when I want the 4 levels of measurement, I make that D into an R. And I've got nominal, ordinal, interval, and ratio. That's my way of doing it. If you come up with an even better way of doing it, because it's hard to remember just NOIR because it's not a word. Even spelled backwards, it doesn't make any sense. So if you can come up with something great, I would love to hear about it. So Noid, and change the D to an R, you get nominal, ordinal, interval, and ratio. Next, once you got those down, what do they represent? Well, first of all, nominal means you just got labels or names. No numbers. So we're talking about qualitative data. Oh, by the way, before I go on, since this is the football season anyway, now I'm not an artist, so pardon me. Here's our football player. Now our football player has a uniform on, and what you see on his back is a number. Now, 49 looks like a number. And you think, okay, so our favorite player has number 49. Does the 49 represent a nominal or one of the other levels? Well, actually, the 49 has nothing to do with the actual player. All it is just a word, actually. So this is an example. The numbers on the back of the players represent nominal labels. In fact, on the back you'll see the 49, and let's say this guy's name is Jones. Both the Jones on the back of his uniform and the 49 are both labels. names. So that's a nominal level of measurement. You can't add those, you can't subtract them. If your two favorite players on the team are 49 and let's say 31, those are your two favorite players. Maybe they're friends of yours. 49 enables you to identify the player. The 31, same deal. But what you can't do is take the 49 and add 31. That doesn't make any sense because the 49 and 31 are not used as numbers, they're used as identifiers or labels. Next. So, nominal level or not. Hit the pause button, write down your answers for A and B. First one is about the favorite pizza topping and why is it nominal. So ask yourself, is it a label or a name? For part B, you want to know the number of students whose favorite topping is sausage. Why is it not nominal? Well, the number of students isn't a label, isn't a name, so it's not nominal. Toppings and the count of students who prefer sausage. Next, ordinal. Just a little reminder here, our levels are N for nominal, O for ordinal, and we'll have I and R coming up in a moment. Notice with this one, if you look at the very beginning of this, if you didn't see the last four letters, but just knew that there were a few letters afterward, you might guess it was order. Well, that's exactly what it is. Now, it doesn't have a number that you can add or subtract, but it does have a certain order, so it's ordinal. Ordinal can also be a name. In some cases, it can be a label, but there's an order to those. Now, I have these sort of backwards because when you're thinking of levels of measurement, you should be thinking of it this way. If you're going to do any kind of statistics with these data, nominal, frankly, is sort of the worst. There's not nearly as much that you can do with nominal data as you can for the ordinal data. Even better is interval data, and best of all, the ratio data we're going to come to in a few minutes. So we've got a hierarchy. Nominal, better is ordinal, even better yet is interval, and better yet the best ratio data. So nominal, name or label. Ordinal, you can put them in some kind of order. For example, if you were looking at a list of, let's say movies, you might put a certain one first, another one second, third, fourth. But you can't add the movies and get anything that makes sense, but you can put them in an order. Best to worst, worst to best, whatever you want to. Next, a little bit of a check for you. Nominal or ordinal data. Hit the pause, write down your answers, and come back. Okay, you look at the seat numbers. Oh, you see some numbers there. You get excited. Well, can I do anything with those numbers? Is there an order to it? Can the genres of music be put in some kind of order? Well, let's see. Seat numbers are ordinal because there's a meaningful order. The A23 comes before A24. Now, frankly, my personal take on this is it depends on where the seats are, whether there's an order to them. If you're talking about left to right, that might be an order. Genres of music, no order whatsoever. You might have a preference, but as far as just the genres are concerned, it's purely nominal. Next. So remember, we talked about nominal. Nominal is in name only. Ordinal, you can put them in an order where you can't with just nominal. Next is interval. Now, the thing that's different about this is that definitely it's numeric, and not only can you put them in an order, but the differences make sense. And perfect example is temperature. So if it's 86 outside right now, first of all, you could consider it as nominal, but if you take the 86 degrees and 94 degrees next day, you can put them in order. So temperature is also ordinal. Is it interval? Can we take it that far? Yes. You can subtract the 86 degrees from 93 degrees, and you can tell what the temperature difference is between the two. So this is actually interval. Is a ratio? Well, we'll see in a moment. How about the birth years of your classmates? What level of measurement? Nominal? Or is it better, is it ordinal? Better yet, interval? Or is it a ratio? Remember, this is birth years. So what's the answer? You can put them in order, so it's more than nominal. You can also subtract them, so it's interval. But take a note, if someone were born in the year 0 AD, that doesn't mean it's the beginning of time. If the 0 does not represent none, then it only goes as far as interval. So what's the next one? The last one is ratio, and this one has characteristics of a nominal one, sort of boring. Ordinal, yes, you can put numbers in order, like the lengths of 2x4s, for example. You can also subtract them, so it's interval level. Excuse me. And better yet, it's ratio level because a 0 on these means the absence of something. If you had 0 2x4s or 0 light bulbs, you would have none of them. So that means ratio level. Not only that, 0 point means you don't have something, but it also means you could talk about the possibility of one pile of pencils having twice as many as another one. That's another indication of ratio. That's how you form ratios. One number divided by another number. If you can do that and the 0 point represents something that doesn't exist, you've got the ratio level. And you've got the greatest number of options when you're doing statistics on it. How about this one? The ages in whole years of U.S. presidents when they were inaugurated. So we're not going to mess around with decimals or or fractions of any kind. What level of measurement? Remember, 4 choices: nominal, ordinal, interval, ratio. By default, it's at least nominal. Could you put them in order? Can you subtract them and get something? Can you divide one by the other? And the 0 mean none. Answer? They're measurable, ordered. 0 means no life or just born. And you can say someone is 1.8 times as old as someone else or twice as old as someone else. Now some pictures, qualitative versus quantitative. Remember, the quantitative have numbers associated with them. Name or label means you've put qualitative data. And you might remember how large this polygon is. It's larger than the other one. That might remind you that you can do more statistics with quantitative data than you can with strictly qualitative data. Although some things can be done, and we're not going to explore that totally. You'd have to take many, many courses to learn all of that. Nominal and ordinal or qualitative. I sort of messed that up, didn't I? Interval and ratio are quantitative ones. Here's a chance again for you to check these out. Notice you've got several answers for each one of those, for A, B, C, and D. Because first of all, you want to find out whether it's qualitative or quantitative. Second, discrete versus continuous, or neither. And third of all, what's the level of measurement? Nominal, ordinal, interval, or ratio. Write down your answers. 3 answers for each of those. Then come back and see how well you did. Finishing times. Definitely ratio level. And also continuous. Colors, qualitative. You can't put them in order. So you've got nominal, quantitative for these, and so on. You can read that. So how well did you do? All right, I guess we finished section 1.2 on data classification. What kind of data are you going to be working with? Remember before we end that it all starts with some kind of a question. A question, and part of that question involves what population are we interested in, and what thing about those items are we going to be totally interested in. Are we interested in everyone in South Carolina? That would be the population. Or perhaps you're interested in the eye color in that population. That would be the characteristic. All right, I'll see you again in section 1.3. We'll get to 1.3, 1.4, and I might even make a few comments about some of the technology we're using. Until then, I'll see you later and keep smiling. Bye-bye.